All right, guys, we're going to go on and get started going over the review sheet. Now, the first thing we're looking at is problems 1 through 6. So if we want to name the circle, we name it by its center. So we can say circle A, or I believe I did say circle A. We can use one of these two here. Now, if we do want to name the radius of a circle, we use the center to a point on the circle. So AD would be a center. We can also say AC or AB. And since it is a line segment, we do need to put the line segment symbol above it. Any questions on 1 or 2? Question number 3, name 2 chords. A chord is any line that connects 2 points on a circle. So EG would be a chord. We would also have BC. Any line that connects 2 points on a circle. Huh? FG would not be because F is not on the circle. It has to be on the circle. AD would be a radius, because A is not on the circle. A chord is 2 points on the circle.
So both points have to be on the edge?
Both points have to be on the circle, yes. Yeah, so not in the middle, it has to be on the circle. So the diameter is CB or BC, either one. Because the diameter is a chord that goes through the center. Number 5, name a secant line. So a secant line is is a line that intersects the circle in 2 points. So EG. It would be different because EG is a line that goes through it. A chord, it connects 2 points. EG is a line, so it goes through it. So we draw arrows to signify that it is a line and does not stop on the circle.
So it intersects the line at 2 points.
Intersects the circle at 2 points, yes. EH, yes. Yes, EH would work. HG would also work, as long as we signify that it is a line and not a segment. Because HG, well, if it's a line, it keeps going all the way through. Yep. Now, if you did a segment above it and not a line, that would be different. Any questions on number 5? Number 6, a tangent line. HJ, HI. HJ would be the tangent line, and point I would be the point of tangency. Any other questions on 1 through 6? Are we good with problems 1 through 6? Seven would be internally. And the main way I keep them straight is if the tangent line goes between them, it's internal. If it doesn't, then it is external. 8 would be externally, because it does not go between the 2 circles. If the tangent line goes between the circles, it's internal. If it doesn't, it is external. Any questions on 7 or 8? Questions on 7 or 8? Let's look at 9 through 11. So if a line is tangent to the circle, then it makes a right angle. So for these here, we're going to be using Pythagorean's theorem. So if we look at number 9, point B is the point of tangency. So at that point, we should have a right angle. Now that does make 25 be the hypotenuse. So we're saying that 15 squared plus 20 squared should equal 25 squared. Now we can do this in a calculator. 15 squared plus 20 squared. 15 squared plus 20 squared is 625. The other side is 25 squared. That is also 625, so this would be, yes, it is tangent. Questions on number 9 or 10 or 11? Questions on number 9? Now, number 10, we're told that the distance from the center to a point on the circle is 16. That means the other side is also 16, making the whole side 32. So what we're saying here is that 63 squared plus 32 squared should equal 65 squared. Because again, point B in this case is our point of tangency, which means we should have a right angle there. Now we can plug this into the calculator and see what we get. So 63 squared plus 32 squared is 4,993. Then we can do 65 squared in the calculator and get 4,225. Are these the same? No, so not tangent. Questions on 9, 10, or 11? Questions on any of these here? We ready for the next one? Points B and D are points of tangency. Find the value of x. So if we have two tangent lines connecting to a point outside the circle, they are congruent. So here we're saying that 2x squared plus 4 is equal to 22. At this point here, we just need to solve for the value of x. So we can minus 4 from both sides, telling us that 2x squared is equal to 18. At this point here, we can divide both sides by 2, telling us x squared is equal to, then we would square root both sides, yes, telling us x is equal to plus or minus 3. Because the positive or negative case does work in this here because our original equation is 2x squared plus 4. If it does have a square to begin with. Now, if you're not sure and you want to check, we can always check it, put it back in. Because 2x squared plus 4 should equal what? 22, yes? So I can plug it back into the original length. Because the original length was 2 times x squared plus 4, so we can say 2 times negative 3 squared plus 4 gives us 22. I can also do it with positive 3 and get 22. So if you're not sure with the plus or minus, go on and plug it in with both the positive and negative case. Take which one that works. Here, both of them work. Any other questions on number 12? Questions on number 13? So 13, again, these two lengths are going to be the same. So 5x minus 14 is going to equal 3x plus 10. Now, I'm going to subtract 3x from both sides first. I mean, we could have added 14 to both sides or subtracted 10. But doing this here will tell us that 2x minus 14 is equal to 10. At this point here, we can add 14 to both sides, telling us 2x is equal to 24. Divide both sides by 2, and x is equal to 12. We don't add the plus or minus because we did not take the square root of both sides. We only add the plus or minus if we take the square root of both sides. Questions on any of this here? We ready for the next one? Questions on 14 or 15?
So, the way that it's like, would it be like,
if we take the square root. If we take the square root of both sides, then we have the plus or minus.
So anytime we get a square root, we always have the plus minus.
For most part, yes. Yes. So this is the same as number 12. So they're both going to be the same. They're going to set equal to each other. And the first thing we can do is add 15 to both sides, telling us that 6x squared is equal to 4. Carry the 1, 2. Now at this point here, we can divide both sides by 6. So we're going to take 294 and divide it by 6. Is at this point here, we have to square root both sides, telling us x is equal to plus or minus 7. Because 7 times 7 is 49. What's negative 7 times negative 7? Because we're looking for a number times itself, that gives us 49. And positive 7 or negative 7 works. And if we look back at the original problem, the x is being squared, so both of them do work. If it had just been x, then there's a chance that one of them will not. Any other questions on this here? Any questions on number 15? Okay. Questions on 16 through 21 on finding the measure of the arc.
Major is 180 below, and minor is 180 below, or minor.
Minor is less than 180. Major is greater than 180, and semicircle is equal to 180. So if we're looking at A, B, D, we would add these three together. So we'd say 140 plus 40 plus 39. 9, 8, 9, 10, 11, which would be 219 degrees, and this would be major. And that's it. Is there any one of these other ones that we want to see? I would like it, but I'm not going to count off if you don't include it. Any other questions on 16 through 21? So one thing I would make sure is to classify as major, minor, or semicircle, and definitely get the angle, because if you don't, I will count off half. Because there's a point for the angle, point for labeling it, and a point for doing it. So I would include. Yep. Questions on these here, 16 through 21. We good with 16 through 21? Questions on 22 or 23? We good with 22 and 23? 23. Now we know the two circles are congruent because the radii are told to be congruent. And since the central angles for these two arcs are the same, yes, they're going to be congruent because the central angles are the same, so the arcs have to be the same. Find the indicated measure. So looking at this here, EF, X, well, since these arcs, these chords are the same, the arcs have to be the same. So X has to be 104. AB is told to us to be 6. BC is told to be 6. The measure of AEB is 120 degrees. So this has to be 120 degrees also, because if the chords are congruent, the arcs that connect them are congruent as well. Questions on 24, 25. 26. Well, if the central angles are congruent, it means these arcs are also 60 degrees. Therefore, AD and BC must be congruent, and if one is 12, the other has to be 12.
So these are just bindings that are
Yep. So DC would be 10, since AB was 10, and it shares its arc is 47, DC's arc is 47, therefore chord AB has to be congruent to DC. Questions on this here? 28 and 29, which one do we want to look at? 29. If the diameter intersects a chord and makes a right angle as perpendicular, it bisects not only the chord but the arc. So these two chords, or parts of the chords, are going to be congruent. The two arcs are also going to be congruent. So y minus 5 is going to equal 40 plus 5, 45. Now we also know that the two segments, 4x minus 36 is going to equal 2x plus 24. They're going to be congruent. So we can set them equal to each other and solve for the value of x. We can minus 2x first, yes. Telling us that 2x minus 36 is equal to 24. Almost. Because 2x would equal the 1. So y is 45 and x is 30. 29, or not 29, 28's nice. The two arcs are the same, so y is. Two chords are the same, so x is. Questions on 28 or 29? We good with these two here? We will come back to 30 and 31. I want to make sure we get time for everything else first. Inscribed angle. An inscribed angle is equal to half the measure of its arc. So here the arc is 164 degrees. So the measure of angle D is half the measure of ABC. So here the measure of angle D is 1/2 of 164. So the measure of angle D is 82. Now the same thing is true with 33. The measure of AD, the measure of the arc, is equal to twice the measure of the inscribed angle. So the measure of AD is equal to 2 times 37. So the measure of AD is equal to 74. So to go from an inscribed angle to an arc, we multiply by 2. To go from the arc to the inscribed angle, we divide by 2. The arc measure will always be bigger than the inscribed angle. And central angles are the same as their arcs. Yes, so really all of these should have degrees. No. Any questions or other questions on 32 or 33? We ready to look at the next two? 36. If we have an inscribed quadrilateral, the opposite angles add together to be 180. So y plus 69 is equal to 180, and x plus 102 is equal to 180. For y, we would subtract 69 from both sides, telling us y is equal to 111. And for x, we would subtract 102. So x is equal to 78. Any questions on either one of these here? Okay. Any questions on this here? Any questions on 37? We good? Feel good about these here? Because 37 would be the exact same thing, except for it would be 4x plus 47 is equal to 74, yes. Questions on these here? So we minus 74. Scroll down just a little bit. Telling us 4x is equal to 106. We would divide by 4, telling us x is 26.5. Yes. 106 divided by 4, 26.5. We would do the same thing with y. Say 3y plus 102 is equal to 180. We would subtract 102 from both sides. Divide by 3. Y is equal to, I think, 16. Or not 16, 26. Because y is 3, we go into 7 twice, giving us 18, which would be 6. Questions on either one of these here? Is inside a quadrilateral, the angles opposite each other, add together to be 180. We good with 36 and 37? We ready for the next two? So this one here, whenever we have a triangle and two sides, or one of the side is the diameter, the angle opposite the diameter is going to be 90. So we can just set 4x equal to 90. Yes. Thanks. Now we also know that the acute angles in a right triangle add together to be 90. As the diameter is half the circle, so that arc is set to be what? 180. So 4x is an inscribed angle to an arc measure of 180. It's equal to half that, so it has to be 90. So we could set it as 90. So we could say 90 plus 42 plus 2y is 180. If we add those two together, we get 2y plus 132 is 180 minus 132 from both sides, telling me that 2y is equal to 48. Divide by 2, telling me y is 24. We could have also said that 42 plus 2y is 90. Because if I take 90 away from both sides, it does work also. Any questions on 38 or 39? We understand how this works? Yes. We're ready for 40 and whatever, 41 probably. So we know arc AD is 75. ACD, well, the whole circle is what? 5, 10. So the rest of the arc is going to be, so the measure of arc ACD is 285 degrees. Now, angles 1 and angle 2 are half the measure of their arc. So half, to find the measure of angle 2, we're going to take half of 75. So the measure of angle 2 is 32.5, I believe. 75 divided by 2 is 37.5. 37. Goes off slightly. 37.5. And for the measure of angle 1, we can take half of 285. 142.5. Now, if you do notice, angles 1 and 2 is part of the tangent line. It does make a line. Yes? No. Because again, on the test, the first place I do look is at the answers and see what you get. If it's off, then I look back at the work. Does that make sense? Mm-hmm. I do get partial credit and go back through it. Yep. Nope. I look back through it to see what you got. Now, angles 1 and 2 for this here that make that line should add together to be 180 because it is a straight line. Now, angle 1 is 49, and as I just said, 1 and 2 should make a straight line, so they should add together to be 180. So I can subtract 49 from 180 and exactly and get. Now to go back to the arc, we'd multiply it by 2. So AB would be 2 times 49. So the measure of AB is 98. Measure of BCA or ACB is 131 times 2. So the measure of BCA is 262. Questions on how we found 40 or 41? Because I think we should be closing in on the end. Yes? Okay. Yes. Well, yes, but I won't be up here. Yes. Yes. We should. So guys, for this here, if the two lines intersect outside the circle, it's bigger minus the smaller. So here, we'd have 34 is equal to 1/2 of the bigger arc minus the smaller. So here, we'd have 3x minus 2 minus x minus 6, because we have to distribute the negative. Now 3x minus x is going to be 2x. Negative 2 minus 6 would be negative 8. Now at this point here, we can multiply both sides by 2. Now we could have multiplied or distribute the 1/2 through. Or we can multiply both sides by 2, because the 2 times 1/2 will cancel. At this point here, we can add 8 to both sides, telling us 2x is equal to 76. Then we divide both sides by 2. When we divide both sides by 2, we get x is equal to 38.
So if I can write that.
If they intersect inside the circle, angle is equal to just the 2 angles added together. So y in this case is going to equal 1/2 of 73 plus 111. Well, 73 plus 111 is going to be 184, and half of 184 is 92. Now x and y do make a straight line, so to find x, I'm going to subtract 92 from 180 and get 88.
So for like the intersection.
Yes, when they intersect inside the circle. Yep, looks like we might not. Yep. Any questions on this here? Okay, that's fine. And bigger, but it's just angle.
Lena, Flores, please come to the office. Lena, please come to the office.
We go back to 31, 32.
So most likely, if they're not in the review video, will they be on the test?
No, I know that.
Yeah.
I'm just saying, I know.
Yeah. Any questions on any of this here? We will, because there are a few more, I will do this, we'll finish this tomorrow, and your test will be Wednesday.